In the next two lectures, we're going to take a closer look at each of the planets individually. In this image, you can see a size scale model similar to the drawing assignment we did. Notice just how small those inner planets are compared to the outer ones. Ancient people knew that the planets were different than the stars. Even though they look like stars to the naked eye, watching closely over time, you can see that the planets move through the sky over time as compared to the background stars. That's why the Greeks called them wanderers. Here you see an image illustrating that motion, specifically the retrograde motion that we discussed with Mars back in Unit 1. Background stars stay in the same positions relative to each other, but planets appear to wander through the stars. In fact, these wanderers, plus the sun and the moon, were so obviously important to early people that they actually named the days of the week after them. In English, it's easy to see for the 3 days of the week. Sunday, the sun's day, Monday, or moon day, is the moon's day, and Saturday is Saturn's day. The other days are easier to see in other language. Martes is Mars, Miércoles is Mercury, Jueves is Thursday, and Viernes is Venus. In English, these don't match up as well, but that's because English comes partly from Germanic languages rather than the Romance languages like Spanish and French. Wednesday is Woden, the Germanic equivalent of Mercury. Thursday represents Thor's day, the guy with the hammer. And Friday is Frigg day. Frigg is Thor's stepmom. In this image, you can see the axial tilt and rotation directions of the planets. Notice that Mercury and Venus are barely tilted at all, while Earth and Mars are tilted almost the same amount. Notice also that Venus is the only planet that spins clockwise. All the other planets spin counterclockwise. Venus's retrograde spin is probably the result of a large collision in its past that actually altered the spin direction. Here is an image of Mercury, actually a lot of images of Mercury. You should be able to see that this picture is a composite image, made up of many smaller images pasted together. You may also notice that Mercury looks a lot like the moon, gray and cratered. Here is a more complete photo of Mercury. Mercury is a sun-scorched planet, less than half an AU away from the sun. It's also small, only slightly larger than our own moon. It has almost no atmosphere and thus is covered with craters. Earth and Venus have many fewer craters as most would-be impactors burn up in their atmospheres. Because Mercury lacks an atmosphere, there's a huge difference in temperature between the lit and dark sides of the planet. If you were on the daylight side of the planet, it would be a scorching 800 degrees, while on the night side, a freezing -300. This is the widest temperature shift for any planet. There's evidence that in deep craters, ice exists on Mercury. Here you see one of the polar regions of Mercury. Since Mercury's axis has almost no tilt, this area is never angled toward the sun. In deep craters, there are areas that never receive sunlight, and radar images suggest that ice exists in these craters. Sunrise on Mercury is also a strange thing. Mercury has what is called a double sunrise, where the sun begins to rise, reverses, traveling backwards, and then reverses again to its original direction. The reason for this is that Mercury has a fairly elliptical orbit, meaning that it travels much faster at perihelion than at aphelion. This, coupled with Mercury's slow rotation, produces this strange phenomenon. If you click through the PowerPoint in slideshow mode, it will load a video that explains this pretty well. The video won't play in my lecture recording due to compatibility issues with YouTube. I've also provided a link to this short 2-minute video in the Unit 2 module. This is the slide where the video plays in the PowerPoint. Here you see another composite image of Mercury. These photos were taken by the Mariner 10 spacecraft back in the 1970s. As it was a flyby mission, meaning that all it did was to literally fly by Mercury one time, it only was able to photograph half the planet. The other side of the planet was in darkness and couldn't be imaged. Mercury's atmosphere had been found to have almost entirely boiled away due to the extreme heat and the inability of the planet's gravity to hold on to it. Small amounts of sodium were found in the atmosphere, perhaps evaporated out of the rocks. This image is not a composite. This was filmed by a much more recent craft called Messenger. Being 30-plus years newer, the equipment on this spacecraft was much improved. Messenger was also an orbital mission, not a flyby, so it was able to collect a lot more data. It arrived at Mercury in 2008 and continued to study Mercury for 7 years until it ran out of fuel and crashed onto the planet. Yes, we've littered on Mercury. The Bepi-Colombo spacecraft, launched by the Japanese and European space agencies, is currently on its way to Mercury. The spacecraft will be making a series of flybys, 1 of Earth, 2 of Venus, and 6 of Mercury to get to Mercury. But it's necessary in order for Bepi-Colombo to counter the huge gravitational tug of the Sun and slip into steady orbit around Mercury. That's why the trip will take so long. Once there, it will orbit for a couple of Earth years, or the equivalent of about 10 Mercury years, continuing the work of studying Mercury where the Messenger let off. This is a color-enhanced image of Mercury. As you've seen in the earlier pictures, Mercury is not orange and blue, but these colors help to make the different planetary elevations stand out. The blue areas are lower elevation, while the orange areas are of higher elevation. Here you see a cutaway image of the planet. Notice how thick the core is compared to the rest of the planet. It is thought that Mercury was impacted by a large object in its past, and that impactor blew off most of Mercury's crust and mantle, leaving mostly just core material behind. This is why Mercury is so dense compared to the other planets, and why, even though it's significantly smaller than Mars, you'd weigh the same amount on both places. Mercury was probably a lot larger planet before this impact. This large core also provides Mercury with a magnetic field. Finally, Mercury is named for an ancient Roman god. Mercury was the messenger of the gods, and he was very fast. Hermes was the Greek version of the same god. Since the planet Mercury circles around the sun in only 88 days, being the fastest planet, it was named for this speedy god. Notice the wings on his shoes. You may recognize that the Goodyear Tire Company's logo looks like a winged shoe, also based on this god. The image on the left is Mercury's symbol. You'll often see these symbols used on star maps. You don't need to memorize these symbols, but I'll show you the symbols for all the planets as we go through them. Venus is the second planet from the sun. We cannot see its surface. All we can see are the swirling clouds in its atmosphere. Venus is often called the morning or the evening star. Since Mercury and Venus are closer to the sun than Earth, they are always seen relatively close to the sun, either before sunrise or after sunset. But as Venus is both larger and closer to us than Mercury, it's much brighter and easier to see. It exhibits phases like the moon. Remember that Galileo was the first one to see this. Oddly, a day on Venus is longer than its year. This sounds strange to us, but it's totally possible. Remember, a day is just one rotation on the axis, while a year is one complete revolution around the sun. Venus rotates so slowly that it actually makes an entire trip around the sun before it has spun around once. Remember, I also mentioned that Venus has a retrograde or backward spin. It would have had a prograde or normal counterclockwise spin when it formed, like the rest of the planets, because of the way the initial nebula was spinning, but it must have been impacted by something really large that actually caused it to be knocked into spinning clockwise the other way. If you were on Venus, you would never experience a sunny day. The clouds are so thick that sunlight does not reach the surface directly. Sunlight reflecting off these clouds is also why Venus looks so bright to us here on Earth. This thick atmosphere comes from volcanic gases. In this image, you can see some of the volcanic domes. Surprisingly, Venus is actually the hottest planet. You might think that Mercury would be, since it's closer to the Sun, but since Mercury has almost no atmosphere, it doesn't retain its heat. Venus's extremely thick atmosphere is 92 times thicker than Earth's, and it holds in the heat like a blanket. We call this the greenhouse effect. The surface of Venus is hot enough to melt lead, and not only is the atmosphere thick, it's actually poisonous. Most of the atmosphere is carbon dioxide and sulfuric acid. Many spacecraft have visited Venus, several in NASA's Mariner series, and several more of the Soviet Union's Venera probes. None of these spacecraft have survived for more than an hour or two on the planet due to the extreme heat. These spacecraft have shown us that there are dozens of volcanoes scattered over the surface of Venus. Remember that Earth's volcanoes are clustered at tectonic plate boundaries, but that doesn't seem to be the case with Venus. They're everywhere. We aren't sure whether any of them are active to this day. Venus's super thick atmosphere prevents us from seeing the surface features here on Earth. Chances are, though, that Venus may very well have active volcanism. Spacecraft show us that Venus has very few craters, unlike Mercury. That implies that the surface of the planet has been recently smoothed over by lava flows. Some areas seem to have been resurfaced more recently than others. Scientists still aren't sure whether the volcanism was planet-wide or occurred slowly over time in multiple separate events. Each is plausible. One large event, like the impactor that spun Venus around the other way, could have mostly melted the planet, smoothing it out all at one time. Alternately, different volcanoes erupting at different times could have smoothed out things more gradually. Some formations on Venus look similar to the Hawaiian island chain on Earth. Some of the most recent images we have of Venus show hotspots. Look at the colored center image with the red blob to one side of the mountain. This is a more thermally active region. The problem is, we can't tell whether lava is actively erupting from this place or if it's just closer to the surface, perhaps just releasing steam from below. The upper right image shows the same location at two different times. Notice the new red hot spot in the right image that wasn't there in the left image. Here is another image of that same mountain or volcano and the hotspot image at the top. Now compare that to the radar image at the bottom, presumably showing multiple lava flows from the same volcano, meaning that we have evidence of 5 recent eruptions, though we still aren't certain whether recent means really recent or thousands of years ago. Here you can see 2 more close-up images of some of Venus's landforms. Mountains, cliffs, and valleys are common. You won't have to memorize specific names of landforms for Venus, but you should know that the volcanic cones and lava flow formations are common, while craters are relatively rare. Again, this lack of cratering is partly due to craters being erased by lava flows, but also because most potential impactors burn up in Venus's thick atmosphere. Though each of the planets are named for Greek or Roman gods, Venus is the only one named for a woman. Venus is the goddess of love in Roman mythology. Aphrodite is the same goddess, but in the Greek culture. Ancient people named the planet Venus after the goddess Venus because it was the brightest planet and was considered the most beautiful. Almost all of the landforms and craters on Venus are named for famous women. The symbol for Venus is the same as the symbol for female. Mercury and Venus are the only two planets that can ever transit the Sun. That means that we can actually see them as they pass in front of the Sun from our perspective here on Earth. Venus's last transit was back in 2012. If you missed it then, unfortunately, it will not happen again in your lifetime, as the next one is in the year 2117. Mercury transits more frequently, about 13 times a century. The last one was in 2019, and the next won't be until 2032. In this image, you can see tiny Venus passing in front of the solar disk. A friend of mine actually took this photo on the day of the last Venus transit a few years ago. He happened to snap the picture as the plane was taking off from the airport. In the image, you can see the plane coming from the bottom left and its vapor contrail following. Just above the plane, you can see tiny Venus. The other black spots on the Sun are sunspots. There's also a really cool video NASA produced during the transit. This one is only about 3 minutes long. There's a link to this video in the Unit 2 module as well. Make sure you watch it. We won't spend any time on Earth now, as we did that in the last lecture, but I did want you to see that Earth has a symbol too. We study Earth in this class to help us learn about other planets. Now let's move on to Mars, the red planet. From Earth, Mars has a definite orangey red color to it. This rust-like color is actually due to iron oxide in the soil, the same compound that gives rust its color. Through a telescope, you can see these darker patches and even the polar caps as well. Mars is much colder than Earth as it is farther from the Sun. It is also a desert. Many people are confused by that because we ordinarily think of deserts as being hot, but that isn't the case. Desert doesn't mean hot, desert means dry. Antarctica is actually a desert too, as very little new precipitation falls there every year. Though it is a desert, Mars's axial tilt means that it does have seasons. The polar ice caps change based on the seasons. Mars also has volcanoes, canyons, and weather. We even see signs of ancient rivers and oceans on Mars, though the atmosphere is too thin to keep liquid water on the surface today. As a Martian astronaut, if you carried a glass of water outside on Mars, it would boil away, even though it is quite cold. There isn't enough atmospheric pressure to keep the water pressed down into a liquid. Here is an image of Mars's North Pole. It is made mostly of water, H2O ice. In winter, some of the carbon dioxide in the atmosphere even freezes out onto the pole, making the cap even larger. The south pole of Mars is even colder and always has some CO2 or dry ice. The south pole is colder due to its high elevation. As I mentioned, we do see evidence of past water flow on Mars. This indicates to us that Mars's atmosphere was once much thicker and has been lost by the planet over time due to the solar wind and weaker gravity. These channels all flow from higher elevation areas in the south to lower elevation areas in the north. Some scientists still believe that these ravines may have been caused by lightning rather than water, but most all of the evidence points to water existing on Mars in the past. Here is a planet-wide image of the valley networks and outflow channels at the bottom. See how all these paths here are coming out of the higher elevation white areas and traveling toward the darker, lower elevation areas. There was probably an ocean at one time in Mars's northern hemisphere. The picture at the top shows a zoomed-in picture. Notice how many of the different paths the water took at different times toward that crater at the bottom of the image. Clearly, at one time, there was a lot of water. Here is a similar image, this time in true color. Notice the larger channel coming from the bottom right and moving toward the top left of the image, fanning out into a delta. Mars has an actively changing surface, even though the liquid water is now gone. Here you see areas of sand dunes changing. As the seasons change, huge windstorms develop, shifting the sands around. If you saw the movie or read the book The Martian, you saw an exaggerated version of these windstorms. The wind would not knock you over, as there isn't enough atmosphere there to cause that much force. But for sand, it's definitely enough. Here is another image of dunes. Notice their crescent shape. These are called Barshan dunes, and the direction the points face is the direction the dunes are moving. Here is a true color image of Mars and its atmosphere. In the upper picture, you can see the setting sun. Notice how small the sun looks from 1.5 AU away. In the lower image, you can see that Mars has an orangey sky rather than a blue one. This is due to lots of dust particles in the atmosphere. Mars has a more blue sky when winds have been low for a long time, but this is infrequent. Mars is known to have planet-wide dust storms, where even surface features are not visible from Earth or orbiting spacecraft due to the dust clouds. Here are some images illustrating these planet-wide dust storms. Notice in the left and bottom pictures how much of the surface can be obscured by this dust. In the picture on the top right, see how much of the sun can be blocked by dust in the atmosphere. This blockage of solar light can affect rovers on the surface that require solar power. Here is an image showing Mars's rocky surface. Notice again the rusty color caused by large amounts of iron in the soil. The two hills in the background are called the Twin Peaks. Hopefully, you've never seen a tornado, but you've probably seen at least a mini dust devil, caused when wind picks up leaves or trash bits in a tornado-like shape for a few seconds. Mars has dust devils that can be pretty large. In the module for Unit 2, I also posted a 1-minute video of this type of dust storm. They aren't nearly as powerful as the ones shown in the Martian movie, but they can be large. Here is a dark trail that you can see, left behind as a dust devil disturbed the ground over which it moved. In this photo, you can see the dust devil itself in the center as a white column of dust, the dark shadow it is casting to the right, and the trail that it has left behind on the left side. This storm was 1 kilometer high, so it's not on the same scale as your parking lot leaf twister. It can be the size of a small tornado, though not as strong. This is the slide in the PowerPoint where the Dust Devil video plays. Mars was very volcanically active in the past. We don't see any signs of volcanic activity today, but we don't know for sure whether geologic activity on Mars has completely stopped or not. This is a picture of Olympus Mons, or Mount Olympus. This is the largest volcano in the solar system. It is much larger than any volcano on Earth. It is 3 times higher than Earth's largest mountain, Mount Everest. In addition to that great height, it is also extremely wide. If we could move Olympus Mons to Earth, its base would take up the entire state of Arizona. This mountain probably continued to grow for millions, if not billions of years, since Mars has no active plate tectonics to move the mountain from the hot spot, and the lower Martian gravity doesn't have the ability to crush the mountain down the way Earth volcanoes are. Here is a vertically exaggerated image. The mountain is so wide that in a true photo, you would not even see the peak coming up as it is so gradual. I'd like you to notice, though, that on the right side of the image, the scarp or drop-off that you see here, where some of the sides of the mountain have collapsed. Olympus Mons is one of many volcanoes on Mars, many of which lie in what is called the Tharsis region. Here, you can see several volcanoes. The wispy white material is cloud that is forming in the colder, higher altitude regions. In addition to large volcanic mountains, Mars also has a system of deep canyons that are much bigger than the Grand Canyon. This system is called the Valles Marineris. Notice how big the system is compared to the size of the entire United States. These valleys are probably not the result of tectonic movement on Mars. they start near the Tharsis Plateau, where many of the volcanoes are. It's likely that the land bulged up under Tharsis while magma was moving to the surface, and it resulted in a giant set of cracks to the east of the bulge. And similar to those on the Moon and Mercury, Mars definitely has craters. Here you see a couple of large ones and many smaller ones in the center. Many of these smaller craters are secondary craters, meaning that they form as the ejected material thrown out from a larger impact actually rained back down to the surface, creating the smaller craters. Over the years, we've seen many other structures on Mars, some stranger than others. This image was taken by the Viking spacecraft back in the 70s. People for many years thought that this must have been created by aliens. Oftentimes, though, there is a much simpler explanation. A later spacecraft photographed the same area, and it turns out that the face on Mars was just a normal hill. The original photograph had the sun in a different place, casting different shadows, and it was a much lower resolution image. In this one, you can see a much less face-looking structure, but you can probably see where the original features came from in the original image. Here's another crater I like a lot. This crater is affectionately called the Happy Face crater, for obvious reasons. Some craters look even stranger. Craters obviously aren't typically heart-shaped, and this one wasn't either to start with. Can you see, though, the landslide that occurred within the heart? A collapsed wall in weak rock created this heart-shaped structure. This type of structure is called a graben. People have long wondered about Mars and whether it might harbor living things. An astronomer from the late 1800s, Giovanni Schiaparelli, announced that he had seen lines on Mars he called canale, which is Italian for channels. Channels would be natural structures. However, American astronomer Percival Lowell misunderstood Schiaparelli's writings and called them canals, implying that they were artificial structures built by Martians. Lowell believed that the Martians were dying in a horrible drought and were digging canals to reroute water to dry areas. Good imagination, but incorrect. It would be very unlikely for complex life to exist on Mars with a carbon dioxide atmosphere that is so thin. Bacterial life has not been found on Mars, but if life exists on Mars, it's likely bacteria living below the surface. We have sent several spacecraft to Mars, but we have not yet discovered any living things. The Pathfinder mission had a rover called Sojourner that traveled Mars's surface in 1997. Later rovers called Spirit, Opportunity, and Curiosity have also sampled Martian soil, but no definitive proof of life has been found. The twin rovers Spirit and Opportunity landed on Mars in 2004. Each was expected to survive for 3 months, collecting data in the area where it landed. Spirit functioned for 6 years, and Opportunity was still in operation until 2018. It should have lived for 3 months, but it survived 14 years. It had traveled over 26 miles, which is more than 50 times farther than the original goal. That may not sound like a lot, but try controlling a remote-controlled robot from a couple 100 million miles away when you can't see where you're going. You'd drive slowly too. The Curiosity rover is bigger than the other rovers, and it's about the size of a Volkswagen. Curiosity took a selfie using its robotic arm that is not seen in this picture. This is actually a composite image formed from cropping and sticking multiple images together, so his arm holding the camera isn't visible. There's a really cool free app called Spacecraft AR. You can use it to look at and manipulate different spacecraft. You can rotate them, look at them from different angles, and even move the robotic arms. We'll play with it a little bit in the face-to-face classes. These rovers were not intended to look for life directly. They were analyzing soil and atmosphere samples, looking to determine whether the conditions on Mars are or were at one time suitable for living things. Conditions at the surface of Mars are not conducive to life now, though they likely were in the past. Conditions below the surface quite possibly are still favorable to life, and there may be tiny Martian microbes living in the soil. The InSight lander, relatively recently arrived to Mars, is just wrapping up operations at the time of this recording. It carried a seismometer to Mars to study Marsquakes, trying to determine the interior structure of Mars, similar to the manner in which we study Earth's interior. It was also equipped with a probe intended to be sent down about 5 meters below the surface to study subsurface materials and conditions, but this part of the spacecraft failed to deploy properly. The Perseverance rover has been on Mars the shortest amount of time. It is looking not just for conditions on Mars, but evidence of past or continuing life on Mars. It's collecting samples into tubes that are being left behind on the surface of Mars that will be collected by a future mission and returned to the Earth. Often called Percy, Perseverance carried a helicopter called Ingenuity, or Ginny. It was designed to be a proof of concept experiment, something just to prove that flight was possible on Mars. It was expected to last only a couple of weeks and take a handful of short flights. At the time of this recording, it's been in operation over a year, has taken 29 flights with more scheduled, and traveled several miles. Mars has 2 moons, Deimos and Phobos. Phobos means fear, like if you have a phobia of something, and Deimos means dread. Happy moons, huh? As you can see, they are irregularly shaped small bodies. Phobos is only about 17 miles long, and Deimos even smaller at only 9 miles across. The textbook will tell you that these moons are probably captured asteroids, but that's almost certainly completely false. That's an idea that actually goes back a few decades. People assumed that since they look like lumpy asteroids, that they probably are asteroids, but that isn't true at all. Most people, including the author of our book, never did any further research to determine whether that idea was even likely or not. You will be expected to know that the way the book describes these moons is an old idea, which is no longer supported by current data. The newer understanding of what happened is more similar to the way Earth's own moon formed. Here is where the moons came from: Mars itself. Mars has what is called a hemispheric dichotomy, which is basically a fancy way of saying that the northern hemisphere looks nothing like the southern hemisphere of the planet. Notice how cratered and mountainous the southern hemisphere looks. This is the orangey red portion of the planet. Now look at the nice uncratered blue portion. This is showing you a much lower elevation area. It looks like halves of 2 different planets. Phobos and Deimos' chemical compositions are the same as that of Mars. Some large object impacted Mars and erased all the features and created that deep basin in the northern half of the planet. That impactor ejected so much material out into space that these 2 small moons accreted from it. The lower elevation area is where Mars's water would have been billions of years ago. That's also why there are very few craters in that area. It's a younger landform and it was underwater. Mars is the Roman god of war. Ares was his Greek equivalent. The planet was named Mars because from Earth, Mars appears red. Early people thought that there must be very warlike Martians who were always fighting and bleeding all over their planet. Mars's symbol is very similar to the male sign. And finally, this slide is just an image that allows you to compare the sizes of smaller terrestrial planets, Mars and Mercury, with some of the moons and dwarf planets in our solar system. Notice that moons Ganymede and Titan are actually larger than Mercury. Notice also that dwarf planet Pluto is quite a bit smaller than several moons. We'll discuss some of these moons and dwarf planets in the next 2 lectures.